In this question, we have a lift, an elevator that is accelerating upwards with an acceleration of g by 3. Inside the lift, there is a spring block system hanging like this. When the lift is accelerating upwards, the block is at rest. Now at t equal to 0, the acceleration of the lift suddenly stops. So now the block will start oscillating. We have to find the angular frequency of oscillation of the block when the acceleration of the lift has stopped. We have to find the extension of the spring when the lift is accelerating upwards. And we have to find the amplitude of oscillation of the block after the acceleration of the lift has stopped. So now the block is oscillating. So what is the amplitude of oscillation? Now whenever we have a spring block system, the angular frequency of oscillation is always given by root over k by m. In this question, k is given as 500 and m is 2 kg and g is 10 meter per second square. So therefore, omega is simply root over k by m. K is 500, m is 2. Therefore, we get root over 250, which is 5 root 10 radian per second. Now when the lift is accelerating upwards, pseudo force will act downwards in the frame of reference of the lift. And G effective therefore will become G plus A. So now G effective is G plus A. And the spring force will be balancing the apparent weight of the block, because now the block is at rest with respect to the lift. So therefore the spring force Kx will be equal to the apparent weight mg plus A. Therefore x is mg plus A divided by k. M is 2, G is 10, A is G by 3, that is 10 by 3, and K is 500. So this will give us 40 by 3. So here we'll get 80 by 1500, and that is equal to 4 by 75 meters. So this is the extension of the spring when the lift is accelerating upwards. When the acceleration of the lift stops, then the block will try to go to a position where the spring force balances its weight. That is the mean position. So block will try to go to that position. Okay, so let's call that x naught as the extension of the spring in that case. So therefore, now the spring force is kx naught, and this is equal to weight at the mean position. This is the mean position of oscillation of the block, because block wants to go there, and here the forces are balanced in this new condition. So therefore, x naught, the extension at the mean position, will be mg by k, and therefore this is equal to 2 into 10 by 500, that is equal to 1 by 25 meter, which is 3 by 75 meter. So this is the equilibrium position, and this is the extreme position. So therefore the amplitude of oscillation is x minus x naught, When the lift was accelerating upwards, the block was here. Now, when the acceleration of lift stops, this is the position where net force is 0. That is the mean position. So this is what is amplitude. Now the block will oscillate with this amplitude about that mean position. So therefore, this amplitude will be 4 by 75 minus 1 by 25, which is 3 by 75. That gives us 1 by 75 meters. That is the answer.